Okay guys, so we've been talking about taking the derivative of exponential functions, talking about using derivative rules instead of the formal definition. And so sometimes when you get far enough, it's okay to stop and sort of have a discussion on what exactly it is that we're doing. And so I want to go back to the idea that the derivative is a rate of change, right? It is the instantaneous rate of change. Let me use my pen. It is the instantaneous rate of change, okay, which means it is the slope of the tangent line, okay. And so here I have a function f of x, which is a quadratic function, and incidentally it models a position. Okay, so it models a position, and if we were to take the derivative of that function, if we were to evaluate it at, for example, x equals a, then we would get a positive rate of change, which means a positive um, velocity. Okay, if we take the derivative, for example, at f prime of c, then we have a negative rate of change, which is a negative velocity. Okay. However, if we take the derivative at f prime of b, right, x equals b, then we get a horizontal line, a horizontal tangent, and that slope is going to be 0. The slope of any horizontal line is 0. And so that point in particular is very special to this function and to any such function that has a derivative of 0 at some x value. Because at that point, you're going to have, as we've discussed before, you're going to have a maximum or a minimum. And so B is going to be called a critical value of our domain. Okay, it is just a critical point where the function happens to be a maximum, okay, or a minimum. So with that said, let's keep going. Okay, so here we're given an example where we have to take the derivative of this polynomial function, this cubic function. And how do I know I have to take the derivative? Because they want us to find, number one, the slope of the tangent line. Okay, and I made a little change just to make sure that we have something that makes sense. We want to find out when do we have slope that is equal to negative 12. Okay, so the very first thing you want to do is take the derivative of that function. So f prime of x, and I'm not going to be using the formal definition anymore. So just keep an eye out for that. I'm going to take the derivative of that first term. So what is my first thing to do is to leave out the constant outside, then grab that exponent 3, put it at the front, and subtract 1 from that original exponent, so that is going to be 2. Let me use another color for that 15, so I'm going to subtract, leave out the 15 outside, put the 2 out, and then subtract 1 from the exponent, so that's going to be 1. And always remember that the exponent of that x term in front of 24 is 1. Okay, so similarly I do the same thing, leave out the 24 because that's a constant, and then multiply by the exponent and then subtract 1, so I get a 0 there. If we put it all together, we're going to get f prime of x is going to be 6x squared minus 30x plus 24. Okay, so now that I have that, forgive me for those sounds. Now that I have that, I want to evaluate at what x value my derivative would be negative 12. Okay, so here this is what I'm going to do. I'm going to say, okay, well, my derivative is negative 12, so I'm going to put negative 12 equals 6x squared minus 30x plus 24. Okay, So now that I have that, I can definitely factor out a 6 from all of these from this equation. So I'm going to get a negative 2 equals x squared minus 5x plus 4. Okay, let me erase that. Okay, so I'm going to get an x squared. Okay, and so now I'm going to go ahead and solve the equation. So bring in the 2. So this is going to be plus 2 plus 2, and I'm going to have x squared minus 5x plus 6 equals 0. Okay, now what can we do? We can definitely factor. So the factors of this would be x equals let me factor out this thing. So it's going to be minus 3 and x minus 2, and that would be the two factors of my function, which would satisfy the equation. So x equals 3 and x equals 2. So those are the values where the slope of my function, of my original function, is going to be f prime of 3 equals negative 12, and then f prime of 2 equals negative 12. Okay, so let's keep going. We have one more example. Okay, so again, we need to take the derivative because we're finding the slope of tangent lines. So in this case, my function is going to be this right here, f of x equals 2x minus ex over 2. Okay, and we want to find the derivative at x equals 0. Okay, so let's do part A first. So f prime of this function, okay, is going to be 2 times 1x to the 0 minus 1/2. Remember, leave out the constant. What is the derivative of e to the x? We previously said that the derivative of that function is itself. So e to the x. Okay? And in order to understand that, make sure you watch the first part of this lesson. So putting it all together, we're going to get f prime of x is going to be 2. X to the 0 is just 1, so the only thing left is 2 minus 1/2 e to the x. And we want to find the derivative at 0, so simply we evaluate it. We just replace x with 0. So 0, 2 minus 1 e to the 0. Anything to the 0 is 1. So then I have 2 minus 1/2. Okay, and that is going to be 3/2. Okay, so this is going to be part A. Part A. Okay, and for part B, essentially this is what you're going to have to do. So let me write part B right here. Okay, so for part B, what we're saying is f prime of x equals 2 minus 1/2 ex, and we want to find it when the tangent line is horizontal, which means that the derivative, right, equals 0. So f prime of x at that point is 0 because the slope of the tangent line is 0. So we set this whole expression to 0. So we have 2 minus 1/2 e to the x equals 0. And then you solve for that. Okay, incidentally, when you solve, you're going to get you're going to get e to the x equals 1. Okay, and well, the only possible value for that is x has to be 0. Okay, you can solve that instinctively, or you can take the natural log of both sides. So you take the natural log of e to the x equals the natural log of 1. Okay, and so this would give you x equals 0. All right. So with that said, let's do one more example that you're going to need in your Google Classroom assignment. And then after that would be pretty good to go. All right. So this thing says find the third derivative of the following functions. For time's sake, I'm going to just solve this one, and I'm going to leave that as an exercise for you to do. Okay, so let's go ahead. So we need to find the third derivative, which means we need to take the derivative 3 times. Derivative 3 times. Okay, so what's going to be my first derivative? F prime of x, okay, is going to be, leave out the constant outside, times 3x squared, okay, minus 5 times 1 x to the 0. The derivative of any constant is just going to be 0, so plus 0. In order to understand why the derivative of a constant is 0, make sure you go back to some videos that were posted previously. Okay, so here we say that, okay, f prime of x is going to be 9x squared minus 5. Okay, because x to the 0 is 1. Okay, so now we take the second derivative of this function, which is going to be 9 times 2x to the first. Take the derivative of 5, and that's going to be minus 0. Okay, and now we're going to have f double prime is going to be 18x. Okay, take the derivative now. This is the third time that we take this, so the third derivative, f triple prime, is going to be 18 times 1 times x to the 0. So this would be f, you can write it as like that. F triple prime is going to be 18. Okay, and that would be my final answer. So with that said, let me just highlight it. I wish you good luck, and I hope this video was helpful to you. Again, shoot me any questions that you have on the YouTube comments, and send me an email on Google Classroom as well. So